Okay, I wanted to try something a little bit different today. I'm looking at a problem I did recently, which we have here on the board, the integral of tan squared x times secant to the fourth x dx. And through some pretty straightforward methods, I got my solution to this, tan to the fifth x over 5 plus tan cubed x plus c. I'm not going to work out the integral in this video. I'll provide a link to that one if you want to check it out, but it's pretty straightforward methods going from here to here. The thing I thought was interesting was I looked up this solution in Wolfram Alpha and I found they have something really different looking. And the thing I want to try to figure out is, are these two solutions equal somehow? Or if they only differ by a constant, that's fine too for an integral. So to get started with this, I'm just going to use my solution here. And I'm actually going to just drop the plus c's when I do this because we can actually show that these two expressions are equal without the constant. And so for my first step, I want to kind of aim for this. I want to create the 1 over 15. I can create the tan cubed just by factoring. So if I factor out 1 over 15 and tan cubed x, what's going to happen here is to get back to 1 over 5, we're going to need 3 here. And to get the tan to the fifth x, so I can write this as 3 tan squared x. And then here we're just going to have a plus 5. Noticing if I multiply 5 times this, we get back our tan cubed x over 3. But then from here, with this 5, I'm actually going to rewrite this. I want to break this up as 3 plus 2 for our 5. So then what I can do here is for 3 tan squared x plus 3, I can factor a 3 out and write it as tan squared x plus 1. But we have an identity that tan squared x plus 1 is the same thing as secant squared x. So we can actually write this piece as 3 secant squared x. But now from here, I'm going to just take my Wolfram Alpha solution and copy it down and compare to what we have here for my solution. Now at this point, comparing the solution side by side, again, dropping the plus c, I can multiply through here by 15 on both sides just to cancel this. And then we could divide off tan cubed x on both sides and cancel this and this. Now from here, I can use a double angle formula on cosine 2x. What I can do for that is I can write that as 2 cosine squared x minus 1. We still have a plus 4 here, and we have our secant squared x. Well, for minus 1 plus 4, I can write this as plus 3 right here. Then I can just distribute in my secant squared here. Secant squared x times cosine squared x is just 1. So for our first term, we're just going to have this 2 left over. And then for the second term, we're just going to have 3 secant squared x. But now we just have our left side and our right side the same thing in a different order. So we can say this is the same thing. And so we can see that my solution here is the same thing as the solution that Wolfram Alpha has. So after doing this and finding the two solutions are equal, my only question was, why did they do it this way, or what's going on here? So the really confusing part was why they have this cosine 2x plus 4 here. It's pretty understandable that they might want to factor out a 1 over 15. That makes sense. So let me know in the comments if you found some advantage to having a cosine of 2x in this expression. I'd just be curious if there was some reason for this or if it's just a different way to show it. So we'll stop it there. Thanks so much for watching. Have a great day.